Thanks, everybody. So my name's Kenny Campbell with Geosense. We're a British manufacturer of geotech and structural instruments and sensors. So today, I'm here to talk about a new technology we have called the IPI-X. So it's a combination of both an in-place inclinometer and an automated settlement monitoring sensor. Pretty new, about a year old, and there we go. So, first of all, what is an in-place inclinometer? Typically known in our industry as an IPI, permanently installed in a borehole to measure rotation or inclination and displacement, typically lateral displacement of the borehole. Can be biaxial, can also be uniaxial. These days it's mostly biaxial. It's the same exact sensor, and the pricing of the sensor is exactly the same. So the use of uniaxial sensors is pretty much gone. It can also be done vertically, like I said, but inclined at perhaps 45 degrees and horizontal. But most of what I'm talking about and most applications are vertical. With this sensor, 99% of the time you're using a fully automated data acquisition system to collect the data. It's not really something you can use a readout device on. Typically you're looking at automation with ultimately the data ending up on a project-specific website. Okay, so what types of applications? Well, we're here at DFI. Probably the most predominant application that I've seen it used at is in deep foundations, supportive excavation type situations where you have inclinometers around the perimeter of an SOE to measure any lateral deflection. Embankments and slope stability. If the risk is there to warrant the need for automated instruments, IPIs are very useful for this because you get a very immediate notification of any types of movement. Dams, tunnels, especially in new construction tunnels, we'll talk about that a little bit later on as the TBM advances, understanding the behavior of the soils in front of the TBM head is critical. But an IPI doesn't measure settlement. Never has, never will until now. Or does it? So the solution we have, like I said at the beginning, is we're incorporating two technologies, an in-place inclinometer and an automated settlement sensor. One hole combining two measurements. So before this, you would have a borehole for an inclinometer and a borehole for a rod extensometer or perhaps a magnetic extensometer. But now we eliminate the need for those two boreholes, which of course saves quite a bit of money. So doing this by incorporating the two, now you truly have a 3D measurement of your borehole and the surrounding area. High accuracy measurement, particularly with the settlement sensor, we're seeing accuracies and resolutions of about a millimeter. And that's real time, that's in the project. Because it is quite a simple sensor that's incorporated into the array. So I'll take a step back. So what is it? I have some toys. So basically, an in-place inclinometer is typically installed in ABS inclinometer casing. Here in the US, we use 2 3/4 inch. Elsewhere in the world, they have larger diameter and shorter diameter, but typically grooved ABS casing. The IPI goes in, like I said, permanently installed in the casing, and then for the IPI-X, we have a magnet. The magnet gets secured to the exterior of the casing. Anybody who's done this, these used to be spider magnets that had a leaf spring that came off the sides, and the leaf spring was compressed when you put the casing into the borehole, and then you fought for about 2 hours trying to get the springs to release. They never would. It was always a bone of contention. Anyway, so we found through field experience from mostly our UK customers, removing the spider and simply taping the magnet to the casing using very cheap masking tape, paper tape. Then, as you place it down the borehole, tremi grout your borehole as normal, with whatever cement mix is prescribed, and then the water content of that grout will dissolve the masking tape. Thus, you now get a connection from the magnet to the surrounding strata, which is critical. You don't want the magnet attached to the casing so that when the ground settles, it's settling or heaving separate from the casing. That's what was so critical about this crazy spider magnet. Okay, so this gets permanently installed down the borehole, and then we have the sensor, which we have over in our booth, far too big to bring up here, that goes in and is permanently installed, measuring, like I said, biaxial rotation or inclination, and then it has a 400 millimeter sensor around the area of the magnet to measure the position of the magnet relative to the casing. Super highly accurate. Got to be careful when you're installing it because you need to make sure the sensor is actually aligned with the magnet, not above it or below it, because then, well, it won't work. So what are the advantages? Really, again, I keep saying it, half the number of boreholes, but probably the biggest advantage we're seeing with this is in tunneling applications, new tunneling, TBM boring drives, where you can recover the sensor array. You can't recover the casing, but you can recover the sensor array and redeploy it further down the alignment. So what does that really mean? So yes, you can do that with any inclinometer right now, in-place inclinometer, but when you recover it, typically no two boreholes are the same depth. So you can recover it and then add or subtract sensors to the IPI-X array and then redeploy it in the next borehole. So again, think of a TBM. Recently looked at a project that prescribed 150 IPIs and 150 rod extensometers. And using this methodology, we figured out that we could actually monitor that with 18 or 22 IPI-Xs and redeploying them. So as the TBM advances, anybody who works in tunneling will know, usually 400 or 600 feet ahead of the TBM face, they require monitoring to be done perhaps once a week, maybe even once a month. But as it gets closer to maybe 100 feet, 50 feet, they start to require daily monitoring and perhaps even hourly monitoring. Use your automated instruments, the IPI-X, in those scenarios, and then leapfrog them down the alignment. Hence how you can do 150 specified boreholes with only 18 or 20 IPI-Xs. Again, fully automated, using these days with wireless data loggers. In the early days, it was scientific loggers that you needed a lot of specific training in, but nowadays the wireless technology, people like World Sensing, Sensometrics, as an example, have these digital nodes at the top that basically wirelessly transmit the data to a gateway and then up into the mythical cloud. Who knows what happens in the cloud? But don't take my word for it. The proof's in the pudding. I always like to show data. And this is real data from a project in the UK. Nothing special about it. The two data plots at the bottom should look familiar if you work in inclinometers. The A and B axis of an automated inclinometer. And as normal, the top 2 or 3 feet or maybe 10 feet are displacing based on site conditions, equipment driving over the top of them. And then it starts to level out as it goes down the vertical plane of the casing. And then the plot at the top is the settlement sensor. Each color represents a different magnet at different depths of the casing and showing real data, real movement. Pretty straightforward. I've got a booth over here. I've got the sensor over there. It's just far too big. And with a microphone, we'd probably wake up the whole conference center banging it around up here. Any questions? Great. I'm sorry, I can't hear you.
Hi, how easy is it to recover the instrument?
That's a good question. So the question is, how easy is it to recover the instrumentation? So like I said, the casing is grouted in place. This is sacrificial, it's a consumable. in most geotech applications, you don't recover the casing. The IPI has IPI-X as wheel sets, so you basically just pull it out of the hole and disassemble it. They come in typically 3 meter lengths or 2 meter lengths, even 1 meter lengths. Pull it out, disassemble that section, put it on the sawhorse on the side, pull up the next one. If they're deep, realistically, if they're over about 100, 120 feet, you need somebody that goes to the gym quite regularly. And they'll miss going to the gym that night. But yeah, very easily. Then you take it back to the shop, clean it up, do some, testing, make sure everything is still working, redeploy it. Seth?
Hey, Kenny, how much planning is required in terms of the placing of those magnets relative to, say, a segment of the IPI? Like, does that magnet have to be a certain depth below a transition point, or that, between sensors? Like, how does that typically work?
It's a great question. So in kind of the toolbox of geotech instruments, this is closer to more of the advanced section. You need to be very comfortable working around a borehole, working around casing. So what we've learned is that when we submit an order to the factory, the best thing we do, and we do it about 1 week into the build, is to send the client a CAD drawing of what that borehole is going to look like. So now send it to Seth. He knows exactly in scale where each of the magnets are meant to be. He can plan with his driller, go to site, and then we find the best way is to lay the casing out in a clean, dry spot on site, line up your magnets, and then make sure it aligns with where your IPI-X are going to be. Put some Sharpie markings on it, start to tape it up, and then just confirm that it is aligning with the sensor. It takes a lot of planning. You definitely want somebody that's kind of OCD doing it. And then assemble it down the hole. And like I said, it's got a 400 millimeter range. So if you're not really sure what type of settlement or heave you're expecting, you can set it mid-height. But if you're anticipating excessive settlement, you might want to set it above the range or closer to the bottom of the range. Either way.
Kenny, when you specify the rod length, so you got a 3 meter rod length, can you have the magnet 3 meters length, or does it have to be? Is it set at a certain size?
It gets complex at the top and the bottom of the array because you do run out of pragmatic space on the steel sensor, again, that we have in the booth. That's where it gets a little bit challenging. The bottom is quite easy, but at the top, you have to allow space for what we call the hanger assembly. But no, in general, it can go just about anywhere. It's part of why we do this CAD drawing, to visualize how we're making up the sensor. So you might say, hey, Kenny, we want a 100-foot borehole with 10 feet IPI sensors on it, and we might send you a CAD drawing that doesn't have 10 feet IPI sensors. It might have some 5-foot or even shorter to get the magnets in the place you want. It definitely needs planning. Again, that's why we do the drawing.
If one of the magnets slips when you're installing it, do you just lose that data point for the...
Yes and no. Depends how much it slips. So basically, the good thing about this is you can run a manual magnetic exosometer probe down, almost like a portable inclinometer. So you can check where the location of the magnets are. And if it's within reason of our gauge tube, we can make some adjustments to try and get it closer to the magnet. Yeah, and it happens. It's just the reality of it.
Any more questions? No.
We're over here. I've got the sensor over here. I don't want to bring it up. The mic will go nuts. Thank you.
Great. Thank you, Kenny.